Condition for maximum starting torque. In case of a three-phase induction machine also, we discussed what is the condition to produce maximum starting torque. Similarly, in a single-phase induction motor, what is the condition to produce maximum starting torque, especially for capacitor start induction motor. Will you tell me one thing? Suppose you went to a market and you purchased a split-phase induction motor. Once you purchased a split phase induction motor, that means construction is already completed. In that case, main winding resistance and main winding leakage reactance, auxiliary winding resistance and auxiliary winding leakage reactance are going to be fixed values because construction is already completed. What is the only variable parameter which can be controlled externally to a machine? That is capacitor. Only this capacitance value we can control externally because it is connected externally to the machine. Remaining parameters are fixed parameters once the construction is completed. That means, can I write main winding current is going to be a fixed magnitude? Because what is the formula for main winding current? I can simply write it as voltage by impedance. So voltage is V1, impedance is main winding impedance. As I told you, main winding parameters are fixed. Then what is the formula for auxiliary winding current magnitude? That is voltage by auxiliary branch impedance. But when I am talking about auxiliary branch impedance, can I say capacitor is also involved in that, in this auxiliary branch? And this capacitor value is not constant, we can control it. Therefore, magnitude of auxiliary current definitely depends upon capacitor value. Now the question is, what is the value of a capacitor required to produce maximum torque at the time of starting? That means, machine design and construction is already completed. We have to control this starting capacitor value such a way that maximum torque is created at the time of starting. Okay, first of all, what is the mathematical equation for starting torque? Yes, we know starting torque is proportional to main winding current into auxiliary winding current into sine of the angle between the two. What most of the students will say is that to create maximum starting torque, this angle lambda should be equal to 90 degrees. But that is wrong answer. If lambda is equal to 90 degrees, this sine product will be maximum. But our requirement is not only sine product maximum, this entire product to be maximum. Then only maximum starting torque is possible. But out of this entire product, which current is already constant? Main winding current is already fixed. It is constant because main winding parameters are fixed. If main winding current is already constant, can I include this constant current in the proportionality? Therefore, starting torque is proportional to auxiliary current into sine lambda. That means, if we wanted to create maximum torque at the time of starting, indirectly this I auxiliary sine lambda must be maximum. Okay, you have to design the capacitor in such a way that not only sine product maximum, entire this I auxiliary sine product should be maximum. I auxiliary sine lambda should be maximum. If this total product is maximum, then only starting torque is going to be a maximum value. Understand? So now let us understand when this entire product will be a maximum value. Okay, what is the only variable parameter? Capacitor. Try different capacitance values and find out at what capacitance value this starting torque would be maximum. So for that purpose, I will draw phasor diagram once again. From the phasor diagram, I will try to understand what is the capacitance value where maximum starting torque can be obtained. Okay, let's see. Okay, now let me try to draw the phasor diagram. Once again, I am taking voltage as reference. Main winding parameters are fixed and there is no capacitor in main winding. When there is no capacitor in main winding, definitely main winding is like an RL circuit. Current will be lagging the voltage. So, main winding current is lagging the voltage by a finite angle. I don't want to represent it. Main winding phase angle. Next, coming to auxiliary circuit, capacitor is there. And we also know that always capacitive reactance is more than inductive reactance. Therefore, auxiliary current will be leading the voltage. Auxiliary current is leading the voltage. Then what is the angle between this main current and auxiliary current? We will call it as, this is nothing but lambda. This is nothing but lambda. But our requirement is we need lambda or I auxiliary sine lambda. I auxiliary sine lambda. So for that purpose what I will do is that I will just draw a 90 degrees line from this auxiliary current phasor onto this main winding current such that it is making 90 degrees here. Are you observing a right angular triangle now? In this right angular triangle there is a 90 degrees here. This is angle lambda. Next, what is the opposite side of this angle lambda? That will be a sine product or cos product? Sine product. Therefore, opposite to this lambda I can write I auxiliary sine lambda indirectly. Isn't it? I auxiliary sine lambda. So this is I auxiliary, this angle is lambda, then opposite to that it is I auxiliary sine lambda. There is no difficulty here, it is intermediate stuff, okay, just a right angular triangle. Now tell me, to make maximum starting torque, our requirement is auxiliary current should be maximum or this product should be maximum? This entire product should be maximum. This entire product should be maximum means this red color line length should be maximum. I auxiliary sine lambda. This entire red color line length should be maximum. If this length is maximum, indirectly starting torque is also maximum. Catching the point? So, what is the capacitance value? I wanted to develop a mathematical equation now. What is the capacitance value at which this length is going to be a maximum value? So, to understand that, we need to learn locus diagram of simple RL circuits and then implement the same locus diagram concept for our single phase induction motor. Then we can understand what is the capacitor value at which maximum starting torque can be provided. So this is a little confusing topic, but you need to concentrate more. You will learn in electrical circuits also about locus diagrams, and we will implement the same here also. Okay, let me do it. Okay, to start with, I will consider a simple RL circuit here. You see, there was a resistance, there was an inductance, and a voltage is connected across both of them. Can I say this inductor will have a reactance? Okay. Assume the current magnitude is I, voltage is equal to V. Now, what is the magnitude of the current if I ask you? That is simply voltage by impedance, and that impedance is equal to square root of R square plus X square. Okay. Please concentrate all of you, then it will be easy. Now what I am doing here is that, let us imagine this inductance value is changing. Indirectly, the reactance value of the inductor is variable from 0 to infinite. I will start this reactor from 0 value and I will gradually increase it till it reaches to infinite. Just imagine if this reactance is equal to 0, then can I say only resistance will be there? Then the circuit will be a purely resistive circuit. If a circuit is purely resistive, current will be in phase with voltage. So see this, I will be taking voltage as reference here. You see, this is the voltage I am taking. Right now, this reactance is equal to 0. Therefore, circuit is purely resistive. Current will be in phase with voltage. Current will be in phase with voltage. And if I ask you what is the magnitude of that current, tell me. If reactance is 0, V by root over R square, that means simply V by R. This is equal to V by R. Now what we will do is that gradually increase this reactance value. That reactance value is gradually increased. If reactance value increases, what about magnitude of the current? Definitely current magnitude will decrease. And one more thing, if reactance is slightly increased, circuit is purely resistive or slightly inductive also? Yes, circuit will be slightly inductive as well. When it is slightly inductive, current will be in phase with voltage or current will lag the voltage? Definitely current is going to lag the voltage. So, magnitude of the current will decrease and it will lag the voltage like this. You see, definitely the vector length reduces and also it is lagging the voltage. Let me increase the reactance once again. The reactance is further increased. Current magnitude will further decrease. At the same time, if reactance further increases, circuit becomes more inductive, current will lag the voltage by more angle. So, less magnitude of current, lagging the voltage by more angle. Therefore, you see, this is how we will get next time. If reactance is further increased, like that gradually I am increasing the reactance, finally let us say reactance reaches to infinite. Can I write infinite reactance means open circuit? If it is open circuit, what is the magnitude of current? 0. The current reaches to 0 value. So the current started at this point, finally the current end with 0, and if you touch all these vector tip points, it will trace like a semicircle. It will definitely trace like a semicircle. This is what we will call it as locus diagram of this simple RL circuit where reactance is changing from 0 to infinite value. Now can you tell me for this semicircle what is the diameter? Can I say this is the diameter? And what is the length of that diameter? I is equal to V by R. Okay? Fine. Let me take one more example. Fine. Now let us consider a simple RC circuit in which capacitive reactance is changing from 0 to infinite. Now draw locus diagram for the current vector. So once again, current magnitude is equal to voltage by impedance, that is R square plus X square. I will be considering voltage as reference once again. Voltage is the reference. Let me make it more clear. Voltage is taken as reference. Now let us start with zero reactance here. If this is zero reactance, then circuit is purely resistive. Therefore, current will be in phase with voltage. Current will be in phase with voltage. And what is this current magnitude right now? This is equal to V by R because reactance is 0. Next, slowly reactance is increased. Whenever reactance increases, what about magnitude of the current? Definitely magnitude of the current will decrease. And also, when a small reactance is added, circuit is purely resistive or slightly capacitive. So, current started to lead the voltage by same magnitude or reduced magnitude. Reduced magnitude, you see. Current will slowly lead the voltage by reduced magnitude. Vector length reduces, but it is leading the voltage. If reactance is further increased, current will further decrease. Circuit becomes much more capacitive. Current will further lead the voltage, right? Current will further lead the voltage. If reactance is further increased, current will further decrease. Therefore, current will further lead. So gradually this procedure will take place. Finally, let us say reactance reaches to infinite. Infinite reactance means open circuit. Then current reaches to 0 value. So see, current started at this point, finally ended at this point. If I touch all these nodes, it will trace like a semicircle. It will trace like a semicircle. And what is the diameter of this semicircle? The diameter of this semicircle is equal to V by R. Okay. In a similar fashion, we have to draw locus diagram for single phase induction motor also. In that single phase induction motor, which parameter is varying? Capacitor value is varying. That means you will get a semicircle just like this only. Now let us draw that locus diagram for single phase induction motor and understand what is the condition for maximum starting torque. Okay. Okay, let me try to draw locus diagram for this single phase induction machine. Only this capacitor is variable. First, let us take voltage as reference. Okay, I took voltage as reference. Tell me which winding parameters are fixed values. Main winding parameters are fixed values. Therefore, main winding current is also fixed. And it is definitely an RL circuit, current will be lagging the voltage, right? So, let me first draw main winding current. This is lagging the voltage by a finite angle. This is nothing but phi main, right? Phi main. What is the formula for phi main? Phi main is equal to tan inverse main winding reactance by main winding resistance. For time being, let me remove this. This is main winding phase angle. Okay. Now coming to the auxiliary current magnitude and its phase angle will depend upon this capacitor. So now let us start with a capacitor value in such a way that capacitive reactance is exactly equal to inductive reactance. Tell me what happens if capacitive reactance and inductive reactance both are equal, both will cancel each other, then auxiliary circuit becomes purely resistive. If it is purely resistive, can I say current will be in phase with voltage? If a current is in phase with voltage, we will get current vector like this. Yes or not? And what would be the magnitude of that current? Simply V by R auxiliary. Yes or not? And that would be the diameter of the semicircle, isn't it? Now, already capacitive reactance is equal to inductive reactance. Current is purely resistive. Now, gradually I am increasing capacitive reactance. If I increase capacitive reactance gradually, can I say a capacitive reactance started to dominate inductive reactance? In that case, current will slowly lead or current will slowly lag. Current will slowly lead voltage. It is slowly leading voltage means we will get a circle above this voltage phasor. Okay, let me draw that circle. That's all. Fine. So this is going to be the locus diagram of which current? Auxiliary current by varying capacitor value. You see, every tip point of this circle is nothing but different current vectors when capacitor value is changing. From which value to which value we are changing capacitor? Capacitance value is changing in such a way that the reactance is equal to inductive reactance initially, and finally this reactance is infinite. If this reactance is infinite, auxiliary current becomes 0. So the current vector started here and finally end up here. Now every tip point of this circle will represent auxiliary current vectors at different capacitor values. Now you remember what is our final goal here? Starting torque is proportional to I auxiliary into sine lambda. Okay. Now our requirement is to make starting torque maximum. This entire product should be maximum. This entire product means I told you already in the phasor diagram, I auxiliary sine lambda means draw a perpendicular line from the auxiliary current vector such that it makes 90 degrees on main winding current. So what I do is that I will draw different perpendicular lines here. You see, I will draw different perpendicular lines. All these perpendicular lines are representing I auxiliary sine lambda, because I told you this circle is I auxiliary current. If this circle is I auxiliary current, those perpendicular lines are nothing but I auxiliary sine lambda. So if this I auxiliary sine lambda is maximum, then only starting torque is maximum. Can I say out of all these perpendicular lines, can you tell me which perpendicular line is going to be the maximum value? Yes, you can easily imagine this is going to be the maximum perpendicular line length. How do you know that is a maximum perpendicular line? Because that is passing through the center of this diameter. This is the diameter of the semicircle. For that diameter, this is the center point or origin point. This is a simple geometrical stuff. I think you might have studied many times. You take a circle like this, then this is going to be the diameter of the circle, and there is one random line like this. Now you draw number of perpendicular lines. Okay, every perpendicular line is making 90 degrees. Okay, on this. Can you tell me which perpendicular line length will be more? Obviously, the line which is passing through center of the diameter. If this is a center, whatever line is passing through that center, that is going to be the highest length magnitude. The same simple concept I am following here. This is the diameter of the semicircle. This is the center of that diameter. Whichever line is passing through that center, this is the highest perpendicular line length possible. Therefore, I can remove remaining all lines. I can remove remaining all lines. This one as well. This one as well. Okay. Fine. Now, if this is the maximum perpendicular line, what is that perpendicular line? I auxiliary sine lambda. Indirectly, can I say this is going to be the corresponding I auxiliary current? Because I told you every point in this circle is representing I auxiliary only, but at different capacitor values. Now, at what I auxiliary point we are getting this perpendicular line maximum is important for us. So, we understood this is the maximum perpendicular line length. This is 90 degrees now. What is this length is representing? I auxiliary sine lambda, because this is lambda right now. This is little critical to understand, but everybody has to focus. Simple derivation, nothing more than that. It is simple geometry. Okay. Now you see here, this is main winding current. This is auxiliary current. The angle between the two is nothing but lambda. If this is lambda, the perpendicular line is I auxiliary sine lambda. Right now, that length is maximum. How do you know that length is maximum? Because that is passing through the center point of the diameter of the semicircle. Okay, this is the center point, this is the diameter, that's why this length is maximum. You take any other perpendicular lines, their length will be definitely less only. Now you tell me what is, if this is center, what is this angle? Can I say this small angle is nothing but angle between voltage and main winding current, that is phi main. Then what is this angle? This is the angle between voltage and I auxiliary, that is phi auxiliary. Sum of the two angles is nothing but lambda. And one more thing you tell me, let us say this is point A, this is point B, this is point C. And let us assume this is point D. Simple geometry I am using. I told you this is a diameter. If that is a diameter, this is center, can I say this AB length is going to be the radius? And also you tell me what is this BC length also? BC length is also radius, because this is from center to the end of the circle. So AB is radius, BC is radius. That means ultimately AB length is equal to BC length. AB length is equal to BC length. Now you look at this triangle ABC. Triangle ABC. In this triangle ABC, AB length and BC length both are equal. Therefore, you tell me in a triangle, if two side lengths are equal, their opposite angles are also equal. That is a basic principle of a triangle. In a triangle, if two side lengths are equal, their opposite angles are also equal. Therefore, this angle is equal to phi auxiliary. In that case, the opposite angle, this angle also becomes phi auxiliary. Okay? If this is phi auxiliary, this is also phi auxiliary. Okay? That's all. We got what is this angle. When you know this angle, now understand triangle ADC. ADC. Please follow. It is just simple high school level mathematics, nothing more than that. Simple geometry. Look at this triangle ADC. We know in a triangle, sum of all the angles must be equal to 180 degrees. Already what is this angle? 90. What is this total angle? Phi main plus phi auxiliary. What is this angle? Phi auxiliary. Sum of all these angles should be equal to 180 degrees. Let me do it. So therefore, I am considering a triangle ADC. This total angle is going to be phi auxiliary plus phi main, plus this angle is 90 degrees. This angle is phi auxiliary. Overall angle is equal to 180 degrees. Separate phi auxiliary from here. Can I write from this? Phi auxiliary is equal to, if I take 90 to the right side, 90 minus phi main by 2. So this is going to be phi auxiliary equation. If this condition is satisfied, then starting torque would be a maximum value. Will you tell me from the equivalent circuit what is phi auxiliary? Where phi auxiliary is equal to tan inverse. Capacitive reactance is dominating, don't forget, XC minus auxiliary reactance XA by R auxiliary. Okay. Now let us see how to perform the mathematical calculations. Always in the given question, main winding branch parameters, auxiliary branch parameters they will give you. They will ask you what is the capacitor at which maximum starting torque will be created. From the main winding branch parameters, our first calculation is phi main value we will get. Whenever you got phi main, take that value and substitute in this formula. Once you substitute phi main here, we will get phi auxiliary. And substitute that phi auxiliary here, from that we will get XC. Whenever you know XC, you will be able to get what is the capacitor value from XC. So we will solve a numerical question, then you will get more clarity on this. Okay. Alright. Now let us try to solve a question related to this maximum starting torque condition. Look at the question on your screen. The following data pertains to a 230 volt 50 Hz capacitor start single phase induction motor at standstill. Main winding excited alone, voltmeter, ammeter, wattmeter readings are given. Auxiliary winding excited alone, once again voltmeter, ammeter, wattmeter readings are given. The value of capacitance to obtain maximum starting torque is how much in microfarads. So see here, they said initially main winding excited alone. You look at this main winding, resistance of main winding, reactance of main winding. It is excited alone with how much voltage? 100 volt. How much current? 2 ampere. Then how much power it is drawing? 40 watts. Now when you know voltmeter, ammeter and wattmeter reading, you can find out what is resistance and reactance values. First, calculate what is the impedance of main winding, that is voltage by current. 100 by 2, therefore 50 ohms, that is the impedance of main winding. Then calculate resistance of main winding. Can I say resistance of main winding can be calculated using this active power reading? Because active power will be completely drawn by resistance only. Therefore, it is simply P by I square. I square into R is equal to P, single phase. Here P is 40 watts, I square means 2 square, therefore resistance is 10 ohms. When you know impedance and resistance values, reactance of main winding will be square root of impedance square minus resistance square, that will give you reactance, and its value will be 48.98 ohms. So we got main winding parameters. Now the next thing is try to calculate auxiliary circuit parameters in the same manner. What is the voltmeter, ammeter and wattmeter readings? Voltmeter is 80 volt, ammeter is 1 ampere, wattmeter is 50 watt. Okay, this is auxiliary circuit alone. Capacitor is not yet added, don't forget. First calculate what is the impedance of auxiliary. That is voltage by current, 80 by 1, that is 80 ohms. Resistance of auxiliary circuit, simply power by I square, right? Power is 50, I square means 1 square, this is 50 ohms. Impedance and resistance are known, then find out reactance of auxiliary, that is impedance square minus resistance square. This will give you reactance of auxiliary circuit, that is 62.4 ohms. So finally we got main winding impedance parameters, auxiliary winding impedance parameters. Now let us see what is the condition to be satisfied to create maximum torque at the time of starting. Okay, capacitor is now added. We need to calculate how much is that capacitor value. Yes, what is the conditions to be satisfied to produce maximum torque at the time of starting? We know phi auxiliary should be equal to 90 degrees minus phi main by 2. This is the formula you need to remember. How to calculate phi main? Phi main is equal to tan inverse x main divided by R main. Already we calculated that X main and R main values. Just substitute here. Tan inverse. What is the reactance of the main winding we got? 48.98. Resistance of the main winding 10. This will give you phi main value, and if you calculate that, phi main value will become 78.46 degrees. Now what you do, this phi main you have to substitute here. Therefore phi auxiliary will be equal to 90 minus phi main by 2. This will give you phi auxiliary. Let me tell you, this becomes 5.76 degrees. When you know phi auxiliary, tell me what is the formula for phi auxiliary when capacitor is added. We know phi auxiliary is equal to tan inverse XC minus X auxiliary by R auxiliary, because this is after adding the capacitor. So already phi auxiliary is known. 5.76 degrees is equal to tan inverse XC minus, what is the X auxiliary value we got? X auxiliary 62.4, R auxiliary 50. 62.4 divided by 50. So this, if you solve this using your calculator, you will get XC value first. Yes, do it with calculator. I will tell you the value. XC will be equal to 67.4 ohms. Understand? When you know XC value, easily you can find out capacitor value, because what is the formula for XC? 1 by 2 pi FC. Let me continue the calculation. So we know XC is equal to 1 by 2 pi FC. From that, C is equal to 1 by 2 pi F into XC. Already in the given data it was given, it is a 50 Hz motor. Therefore 2 pi into 50 Hz into, what is the XC value we got? 67.4. If you use your calculator, this value will be 0.00004716. So ultimately you can write it as 47.16 microfarads. So that is the value of capacitance we have to add in series with auxiliary circuit, so that maximum torque can be obtained at the time of starting. So everybody should remember this formula. The condition to create maximum torque at the time of starting is phi auxiliary is equal to 90 minus phi main by 2. First calculate phi main. Then substitute that phi main here, you will get phi auxiliary. Once you got phi auxiliary, use this formula. Phi auxiliary means after adding a capacitor, tan inverse XC minus XA by RA. You already know phi auxiliary, you know XA, you know RA, you will get XC. When you know XC, you can find out the capacitor value required to create maximum torque at the time of starting. Okay, this formula is important. Let us try to solve one more question. Look at the question on your screen. In the above problem, that means the previous problem what we have solved. In the above problem, the value of capacitance required to create 90 degrees phase angle between main winding and auxiliary winding currents is how much microfarad? This time they are asking us to calculate capacitance value to create 90 degrees phase angle displacement between main winding current and auxiliary winding current. I told you 90 degrees will never guarantee you maximum torque. When a lambda is 90 degrees, only sin lambda is maximum, but not the entire product. But here we are asked to calculate how much capacitance is required to create that 90 degrees phase angle difference. So that means indirectly phi auxiliary plus phi main should be equal to 90 degrees. Okay, this is the requirement. So to satisfy this requirement, how much capacitance is required? So first calculate what is phi main. Phi main is equal to tan inverse X main by R main. Yes, this is equal to tan inverse. What is the reactance of the main winding? Already we calculated. Same previous problem data I am taking. R main 10 ohms. Therefore phi main will be 78.46 degrees. Now substitute this phi main in this formula. Therefore, phi auxiliary is equal to 90 minus 78.46. Therefore, phi auxiliary is 11.54 degrees. What is the formula for phi auxiliary after adding the capacitor? Phi auxiliary is equal to tan inverse xc minus x auxiliary by r auxiliary. Now phi auxiliary is already known, 11.54. X auxiliary is known, R auxiliary is known, you will get XC. When you know XC, you can easily calculate capacitance C value and complete your calculation. The capacitance value would have been 43.82 microfarads. I am leaving that calculation for you. Do it, you will get this much capacitance value. This capacitance value will guarantee maximum starting torque or not? Definitely not, because this is not the condition to give maximum starting torque. What is the condition to provide maximum starting torque? Phi auxiliary is equal to 90 minus phi main divided by 2. If that condition is satisfied, maximum starting torque is possible, but this condition can never give you maximum starting torque. It will give you higher starting torque but not maximum. Okay, so this is about condition for maximum starting torque.